Operations with radical expressions. First off, in adding and subtracting, both of the terms that you're adding or subtracting must have the same radicand and index in order to be combined, which is one of the first rules. To combine like terms, you must add the coefficients and then keep the same radical. So for example, 2 times the square root of 45 minus 2 times the square root of 5. You then would have to simplify the square root of 45 into 9 and into 5, because 9 times 5 is equal to 45, which then becomes 2 square root 9 times square root 5. The square root of 9 is equal to 3, so that can come out of the radical, which then becomes 2 times 3 times the square root of 5. So then you have 6 square root 5 minus 2 square root 5, which can now be combined. So 6 minus 2 is equal to 4, and then the radical stays the same because that's what your rules up here say. So then the final answer is 4 times the square root of 5. Alright, so for the first sample problem, you have a positive 2 plus the square root of 5 minus 3 minus the square root of 5. So in these kinds of problems, you go straight across. So a 2 minus 3 is going to be equal to a negative 1. Now, looking at the radical, since you have the same index and radical, you can just deal with the coefficients. So there's a 1 right here that is to be understood, but it's very important for this problem because when you have a positive square root of 5, so it's like a plus square root 5 minus a negative square root 5, this turns to a positive. So now you have what is to be an understood 1 plus another understood 1. So your final answer is going to be negative 1 plus 2 square root of 5 because you have the same indexes, so that causes these ones to just be added together. When multiplying radicals, the main condition is that you must have the same index in order to multiply the radical. So your 3 steps for it are to rearrange so that the radicals are together, the coefficients are together. Then factor out the radical or multiply everything. Then your third step is to simplify your answer. So for example, you have the square root of 4 times the square root of 4 equals the square root of 16. Because the index is the same in both this radical and this one, you can just multiply the numbers underneath, which then become 4 times 4 is 16. So the square root of 16, which we know to be simplified as 4, leaves you with your final answer just being 4. Alright, so for the first sample problem, you have the problem 3 plus the square root of 5 squared. So the first thing I'm going to do is rewrite that so where it's easier to see. So it's this 3 plus the square root of 5 squared is equivalent to 3 plus the square root of 5 times 3 plus the square root of 5. So your first step, then you're going to do exactly what you do and FOIL it. You're going to FOIL it just like you would a quadratic. So 3 times 3 is 9. 3 times the square root of 5 is going to be equal to 3 square root 5. Then the square root of 5 times 3 is going to be equal to, again, 3 square root 5. And then the square root of 5 times the square root of 5 is going to be equal to the square root of 25. So now what we do is we simplify and combine and do all of those things. So 3 times the square root of 5 plus 3 times the square root of 5 is going to be equal to 6 square root 5, because you've just combined those like terms, because like we learned with the adding and subtracting, they have the same index and the same radical. So then this 9 is just going to carry down from the problem because that's just from the 3 times 3. And then the square root of 25 can simplify into just 5. So that's going to end up being plus 5. So then what you're going to do now that you have 9 plus 6 square root 5 plus 5 is combine like terms again. So 9 plus 5 is equal to 14. So your final answer is going to be 14 plus 6 times the square root of 5. The second sample problem we're going to do is still multiplying radicals, but it is a little bit harder in difficulty as it deals with letters, and also it's a cubed root versus just what was up here, a square root. So the first thing we're going to do is kind of get all of these things under one radical into just like a big group, which is what step 1 says to do. So you can rewrite the problem in general just to be the cubed root of 6a squared b to the 4th times 9a to the 7th b to the 5th. From then you can even get it out a little more broken down so it's just easier to see. So 6 breaks down into 3 times 2. So you're looking at, again, the cubed root of 3 times 2. And then we're going to skip over these letters for a second and go straight to the 9, which is which is equal to 3 times 3. So 3 times 2 is the 6, and then 3 times 3 is the 9. Now, since one of the exponent rules is with same base, you can add the exponents. So for the a's, we're going to be able to add the 2 and the 7. So that's going to give us times a to the 9th. And then for the b's, you're able to add the 4 and the 5, which is also going to give you b to the 9th. So now, since we're looking for a cubed root instead of a square root, we're going to be looking at things in groups of 3. So, as you can see, there are 3 3's here. So that's a group that can come out from underneath the radical. So now we're looking at 3, because you bring out all of the 3's, and that's one group of 3's. So you bring out a 3 of the cubed root to then now what is 3 cubed root of 2 times a to the 9th, b to the 9th. And without writing it out, you know that 9 is equivalent to 3 groups of 3 because it's divisible by 3. So you're able to bring out 3 a's because a to the 9th is equal to 3 groups of a's. And then same with the b, since it's also a 9th power. So what you're going to end up doing is, and I guess another way to look at that is like a times a times a times a times a. 1, 2, 3, 4, 5 times a times a. Okay, so this is a to the 9th is equivalent to this. So if you group this in groups of 3, that's that's what it would look like. That's how you get the 3 groups that come out, in case that comes across as confusing. So, and then the same thing falls for the b, since they're both to the 9th power. So you can end up bringing out from under the cube root a 3, which was from the earlier parts of the problem. And then you have a cubed, b cubed. And so that's what can come out and be simplified. So then now all you have left under the cube root is 2. So your final answer is going to be 3a cubed, b cubed times the cube root of 2.